In this video, we are going to discuss limits, but we're going to take it a step further, and we're going to discuss the numerical limits of functions. All right, so let's say that I were going to give you the function f of x, and I defined it as 2x plus 1. And let's assume that we want to find the limit as x approaches 1 from the left of f of x, which is, I could rewrite this as, I have seen folks rewrite this as 2x plus 1. So one way of looking at this is, what is the limit as we approach 1 from the left for the function 2x plus 1? But instead, what we will really see usually in our textbooks or in on homework is the notation f of x, which is fine because we know that f of x is the same as 2x plus 1. So that's perfectly fine. So how do we do that? So let's think back. Let's think in as in our number line. Let's think of where the number 1 is. 0 would be down here. And let's think of what it would look like or what type of numbers we have on the left side of 1. So what I want to do is I want to create a table. And I'm going to take and plug in values that are on the left side of 1 but are steadily increasing and are increasingly getting closer to 1 from the left. So I may start at 0.9, and then I could go a bit further and do 0.99, and then I could go a bit further and do 0.999. And as I said before in previous videos, you could continue that pattern as long as you want. So what you would want to do is you would want to take these values and plug them into your function. So in this case, that would give me 2 times 0.9 plus 1, and that would give me 2.8. All right, and we're going to do the same for each one of these. It looks like I am approaching which value here. I went from 2.8, 2.98, 2.998. It looks like I am approaching the number 3. So the way that I would write this is that the limit as x, and I'm up here, the limit as x approaches 1 from the left of f of x, that would be equal to 3. Okay, so what we want to do though, it's a big thing with functions, is we tested from the left. All right, now what we want to do here is we want to test from the right. So what we're going to do is I'm going to move this over just a wee bit, and I'm going to make another table here. And this time, I'm going to think about numbers that's approaching, that's getting very close to 1, but from that right side. And some values I could choose would be 1.1, 1.01, 1.001. And again, you could continue this pattern as long as you want, but I think that those 3 numbers will suffice. And our next step here would be to take these values, substitute them into our f of x function to get our output. If I take that 1.1 and I substitute that into f of x, that is going to give me my 3.2. All right, so let's do that again. Let's do the very same thing with f of 1.01. That's going to give. And I think that pattern there, just those three numbers, are enough for us to see that I am going to, as long as I get closer to 1, I am going to approach the number 3. So I can come up here and write this as the limit as x approaches 1 from the right, that's a positive sign, of f of x is equal to 3. Now, I'm going to add one thing to this video here, or to this example. We have a theorem. And my theorem says, I'm going to come down just a bit. My theorem says that if the limit as x approaches a from the right side of f of x equals L, and the limit as x approaches a from the left of f of x equals L, then the limit as x approaches a for f of x is equal to L.